All right, you guys. Okay, so we're going to start up with some warm-ups for 3.9 day 1 because these are skills from Math 3 that you haven't used in a while. I think we taught this back in January. So it's been a long time since you've seen some logs and natural logs. And there were a lot of things that you learned, lots of properties. And if you had me for a teacher for Math 3, you heard about all about the base, no trouble. Right? So you guys remember that? All right, so we need to change each of these to log form. Right now they're in exponential form. Okay, so it's all about the base. This 10 is the base on that exponent. So it's all about the base. So log base 10, but remember you don't have to write a 10 when it's base 10 because that's what it is automatically when you don't see a base there, of 100 equals x. The roundabout, 10 to the, or log base 10 of 100 equals x. What about the next one? We have 2 to the 4th, oops, focus. I don't know why it's having trouble, there it goes. 2 to the 4th equals 16, so it's all about the base. So log base 2, that we do have to write because it's not a 10, of 16 equals 4. You always go counterclockwise when you do your roundabout. Every time I move in front of it, it freaks out. I have a new stand because my other one broke and this one's being like a pain. Okay, I adjusted it, so it should be a little bit better. We'll see. Okay, so e to the a equals b. So whenever it's an e, we use the natural log. So all about the base, because that's technically base e, but we don't normally write that, of b equals a. So you still do the roundabout. Oh, it's still freaking out. Maybe I need to, I gotta figure this out. Okay, anyways, moving along. Then there were some where we had to expand. So expand log of 2xy to the third all over the square root of z. Okay, so remember when things are next to each other, they're being multiplied, and when we expand, that means we need to make it longer, we need to lengthen it, we need to separate these terms. 2 times x times y to the third, remember when we multiply, that means adding with logs. So that would be the log of 2 plus the log of x plus the log of y to the third. And then division, because that's what the fraction bar means, that we convert it to subtraction when we divide. So minus log of, instead of writing the square root of z, let's write this as z to the 1/2 power. Okay. All right, there's still some things that we can do to simplify that because we're not fully expanded. To fully expand, we need to drop those exponents. So remember, they drop in front of the log. So we'll have the final answer, log of 2 plus log of x plus 3 log y minus 1/2 log z. All right. Okay. So next one, simplify. These are the easiest. I remember when I taught this to my students in Math 3 last year, and everyone was like, what? That's it? That's it? And they were like overthinking it and thinking that it's got to be harder than this. But when we simplify these, 10 raised to the log 2 power. Notice this log doesn't have a base. That means it's a base 10. And remember how it's all about the base, no trouble? Well, whenever you have the double base, they cancel each other out, and so the answer is 2. You guys remember that? It's hard. Some of you guys had me. Some of you had Mrs. Ardito. Some of you had Mr. Bonner. So it just depends on how we all taught it, but the rules are all still the same. Okay. Number 6, e to the natural log of 5. Well, there's no base on that natural log, and that's because we assume it to be e. So it's all about the base, no trouble. We've got the double base, so they cancel. The answer is 5. I love the double base. Not just the instrument, but in logs, that's fun. All right, so we're all warmed up now. These are skills that you're gonna need for any time you're dealing with logs in calculus. So we're gonna put that away. All right, so now we're on to the notes section. 3.9 exponential and logarithmic functions, hence the reason why we had those warm-ups. So here is our little cheat sheet of derivatives of exponential and logarithmic functions. Okay, and let's also take note of what the homework is going to be. The homework is going to be from your book, page 178, numbers 1 through 9, odds 15 through 19, odds, and 31 and 35. Those are obviously already odd. Okay, that's 1, 3, 5, 7, 9. That's 5 problems. And then 15, 17, 19 plus 3, so that's 8, 9, 10. So that's a total of 10 problems right there. No big, right? Okay, so we're not going to do all of these examples. This should be pretty quick. We're going to do A and D. Okay. I have all the rest of these done, so if you're curious about any of these other ones on this list from A to F, let me know, and I can show you how to do them. Okay. All right, so we're just going to do these two for this lesson. So we have d dx of e to the 2x minus 1 power, and we need to differentiate. So that means we need to take the derivative. Okay. Well, up here, my little cheat sheet box, I see the derivative of e to the x is just itself e to the x. Oh, that's easy. But e to the x is whatever this exponent is. Okay. So because the exponent has more than just an x, we do have to do the chain rule on that. It keeps focusing weird. Well, let me change the lighting. Okay, I changed the lighting, so maybe that'll make it better. We'll see. Okay, so doing the chain rule on this, let me zoom in a little bit. Okay, so the derivative of 2x minus 1 would just be a 2 times the derivative of e to the 2x minus 1. So we're going to use this. Well, it's just going to be itself, e to the 2x minus 1. So when we multiply that together, it's just, without the parentheses, it looks prettier, 2e to the 2x minus 1 power. And that was it. Not bad at all, right? Like, that's it. These are pretty easy to follow. So I recommend, try to do that one. And if you want to know what the answer is, just let me know. All right, d dx of natural log of x squared plus 1. Well, now we're looking at the natural log one, so we're looking at this one, and it says the derivative of natural log of x is 1 over x. So that's what it's going to turn into when we take its derivative. Our x, though, is an x squared plus 1. And that is a function within a function, so we're going to have to use the chain rule on it, okay? So the derivative of x squared plus 1 would be a 2x plus 0, so just 2x, okay, times now the derivative of the natural log, the overall, and that would be 1 over, our x is an x squared plus 1. Okay, so when we clean this up some more, remember, this is just a 2x over 1, so we'll just bring it to the top of that fraction. So 2x over x squared plus 1. And there it is. Not too bad. I hope you guys feel that way. I haven't gotten any feedback on my homework videos, guys. You gotta let me know if they help you. Otherwise, why should I keep doing them if they're not even helping? So let me know. Even if it helps one person, I'll continue doing it. Because one person matters, right? Okay, So the last lesson had to do with implicit differentiation. So that means we're going to have more than just an x in there. We're going to have x's and y's in there. So we're going to have to do the whole dy dx thing. Okay, so we are going to be doing letter A, and we're going to use implicit differentiation to find dy dx. So first of all, looking at that first term, x times e to the x, I have a product, so I'm going to have to use product rule on that, and that's the only place where I'm going to have to use that rule. So product rule is the first times the derivative of the second. Well, the derivative of e to the x, as we saw up above, is just itself, e to the x, plus the second, which is e to the x, times the derivative of the first. Well, the derivative of x is 1. Okay, those are all x's, so we don't need to add in any dy dx yet. All right, then the derivative of negative 10x is just a negative 10. And now there's a y. The derivative of 3y is a 3, but now I need to attach a dy dx because that was not an x. And the derivative of 0 is 0. The derivative of any constant is 0. And I keep asking those questions on an ed puzzle because I still keep getting answers that are not correct. The derivative of any constant, any regular number with no letter attached to it, it will always be 0. Sorry, I didn't mean to yell at you guys, but come on. I need you to get that. Okay, so we need to isolate the dy dx. So this is going to stay here, but all of this got to go to the other side. So we're going to need to subtract the x e to the x, subtract the e to the x, and add the 10. So we will get 3 dy dx equals negative x e to the x minus an e to the x plus 10. Okay, well, we still need to isolate that dy dx. There's a 3 out front. So we're going to need to move it to the other side. It's being multiplied to the dy dx, so we have to divide by 3. And that's the answer. We cannot reduce that anymore. Thank goodness, right? Because that would look pretty complicated if we tried to. All right. If you want to try letter B, I'm not going to do it for the notes today, but I do have the answer to that. So if you want to give it a shot and see what you get, you totally can. Flip it over. All right, it says to use logarithmic properties, so like what we looked at in the warm-ups, to find dy dx, okay? So we have f of x equals the natural log of x times x squared plus 1 quantity squared all over the square root of 2x cubed minus 1, okay? So first of all, we need to expand this because we can't take a derivative in that format. So let's rewrite f of x. Okay, so f of x equals the natural log of x plus, because they're being multiplied together, the natural log of x squared plus 1, quantity squared. Let me zoom out a little bit. And then the fraction bar, remember, means that we have to turn that into subtraction with properties of logs. And I'm going to convert that square root to the 1/2 power, 2x minus 3 to the 2x to the third minus 1, oh my gosh, to the 1/2 power. So natural log of 2x to the third minus 1 to the 1/2 power. My brain could not keep up with my mouth. That was what was happening there. All right, so we're not fully expanded yet until we drop those exponents. So this exponent of 2 got to drop to the front of the log. This exponent of 1/2 needs to drop to the front of the log. So I'm going to rewrite it, and we'll get f of x equals the natural log of x plus 2 natural log of x squared plus 1 minus 1/2 natural log of 2x cubed minus 1. Okay, we haven't even taken a derivative yet. And don't worry about letter B. We're not doing letter B, so we're going to use the space around it because we need more space. And I'm writing really big, so I want you to be able to see this good. Okay, so now let's take the derivative. Okay, so first off, the first term is natural log of x. Well, on the front of this page, there is that little cheat sheet box that tells us that the derivative of a natural log of x is 1 over x. And then this term, we have a 2 out front, so plus 2. And then we have to do the chain rule on the inside there. So the derivative of x squared plus 1 is a 2x, so times a 2x times, now the derivative of natural log is 1 over the x, but our x this time is the x squared plus 1. Okay, so I'm going to change these to parentheses because that looks better. Minus 1/2 times, I need to take the derivative of the inside. I'm going to have to use chain rule. So the derivative of 2x to the third minus 1 would be a 6x squared. Okay, and then the derivative overall, the natural log, well, that will turn into a 1 over 2x cubed minus 1. Okay, so now we just need to clean this up. So f prime of x equals, I have 1 over x, that's pretty clean, and then I have 2 times 2x, and that's basically over 1, so I'll put it in the numerator, so 4x over x squared plus 1, minus 1/2 times 6x squared, so 2 goes into 6 3 times, so that becomes a 3x squared. And remember, it's going to go, since it's in the numerator, it'll go in the top of that fraction, so 3x squared over 2x cubed minus 1. And guess what? We don't have to do anything further. That is the derivative. Yeah, for a problem like this, I would not tell you, okay, now get a common denominator. No, no, no. I would not tell you to do that. We can, but it's a lot of algebra steps. We don't need to do that. In Math 3 we did because we needed to get used to it and see the process. But in calculus, no, we don't need to do that. All right, next example, or this one's the last one, it's a proof. We need to prove that the derivative of the natural log of x equals 1 over x. One of the derivative definitions on our cheat sheet on the front side. So we need to prove this. So we need to write a proof. Give me the proof. Okay, so first of all, we need to focus on the natural log of x. Okay, so we need to first start off by just let y, some variable, equal the natural log of x. Okay, so what we need to happen is the natural log obviously has to go away because eventually it's going to equal a 1 over x. So we need this to go bye-bye. We need the natural log of x to go poof. Okay, so we need it to somehow disappear. All right, well, back in Math 3, there was a way that we can get the x out of the log. And that means that we would have to raise both sides by an e. So when we do this, we'll have e to the y equals e to the natural log of x. But remember our warm-up? Natural log's base is assumed to be e, because it is. And we got a double base. So x gets to come down. So e to the y equals x. Okay? Well, now that we have this simplified and we got the natural log to go away, let's take a derivative. So it's derivative time. I feel like, oh, what's her name in the Minions movie? What's it called? Despicable Me? Lipstick laser or whatever she says, you know. Anyways, we're going to take that derivative. So first of all, we need to take the derivative of y, which is a 1. And then e to the y will just be e to the y. But because it's with respect to y, it's a dy dx. And the derivative of x is a 1. Okay. All right, well, to solve for dy dx, like we've been doing with implicit, this is an implicit derivative because we have a y in there and not just an x, we have to divide both sides by e to the y to isolate the dy dx. So we'll get dy dx equals 1 over e to the y. Okay. Oh, well, that looks highly familiar because we have this. And we can go ahead and substitute e to the y in. We can substitute an x in for e to the y. So I'm going to write substitute. Okay. So when we do that, that'll be 1 over x. So we just proved that dy dx equals 1 over x. Booyah. I don't know how that's spelt, but that's how I spell it. And that is our proof. We just showed that the derivative of the natural log of x is going to equal 1 over x. There you go. That's it, you guys.